Well, the agenda is, first I want to talk a little bit about licensing. I'm not sure how many in the business are really aware that there's a growing trend in that direction. Licensure of software engineers has been a fact in Canada for a number of years, and it looks like it's gaining momentum in the U.S. There are a couple of states, I know Texas is one of them, that already has a licensing requirement in place. I'm not fully aware of what all that really means, but I think it's something that we may become increasingly concerned about. I think it might become a trend. Most of our focus today is going to be on certifications, and I want to begin by making a distinction between certifications, certificates, and a more recent idea called badges. I'll differentiate those in a minute. I want to give you a little bit of information about the market value of certifications. I think, you know, there's a certain segment of our IT community that are really big fans of certification, really believe strongly in it, and then there's a certain segment of skeptics too. And so I want to talk a little bit about some of the rationale for certification in the first place, what benefits there may be, and what evidence there is that it actually has market value. And then I want to look at a few of the more common software and IT certifications and talk about what some of their requirements are, moving more in the direction now of recertification, that many of them, but not all of them, require continuing education units and a recertification process. And then I want to talk a little bit about the market value of recertification. I guess I will say right up front, I'm a little skeptical about what the market value of recertification is, and as we'll see, there really isn't much data around. I'm hoping that in the question and answer period we can actually have a little discussion. I'd be very interested to know views of the audience, what you think about these notions. And then I'm going to talk about what I'd call a modest proposal. I want to talk about a couple of what ifs. What if the recertification notion was modified from what it typically is today? So, moving right along, licensing, I guess one of the big questions I have is whether software engineering is really engineering. As we probably all know, engineers, professional engineers, are licensed. They have to demonstrate knowledge, competency, and experience, and they can be sued for malpractice. And malpractice would be defined as a failure to establish best practices in the area in which they're practicing. So there's a whole lot of standards, and there's a whole lot of background information about what is expected of an engineer. You know, in the realm of, let's say, an engineer is concerned about building bridges. They have to demonstrate that they've done the appropriate stress calculations and have ordered the right materials and that sort of thing. And if they haven't, they're subject to big lawsuits. And I think originally licensing was grounded in the idea that it's very important to protect public safety. I think one good example of that was in Canada some years ago, a bridge collapsed, and it was subsequently demonstrated that the engineering was faulty. And as a reminder of that, the professional engineers in Canada wear a ring made out of some of the metal from that bridge. So it's kind of a reminder how important it is. And I think it's fair to say, we would probably all agree, there's some software that really does have significant safety implications, as in medical devices. There was an example of a medical device that was used to give radiation treatments for cancer treatment, and the software in it was faulty, and it resulted in overdoses that actually killed some people. So, and then of course I don't know of a specific example where avionics software failed and resulted in death, but certainly there have been examples of, like the Ariadne case, there was a software flaw that caused the rocket to blow up during launch. And of course, we'd all recognize weapon systems have a lot of software in them, and if they don't function right, that becomes very dangerous. I've given you a link here, a LinkedIn group that is an interesting dialogue and discussion around this issue of licensing and whether or to what extent some of these certifications prepare you for licensing. So if you're interested in this topic, you might want to go take a look at that. So certification has a formal definition. Most, and maybe even all, I don't know of an exception, a certification to be, properly called a certification needs to be compliant with this particular ISO standard 17024, and that was released back in 2003, and it is intended to kind of standardize and formalize and define what certification really means worldwide. So basically, what this standard does is insist that anybody who's going to offer a certification formally defines what it is they're going to examine, what competencies they're going to look for, and requires them in a body of knowledge that is explicit and publicly available. It requires that the people who define the certification body of knowledge and design the testing associated with it must be independent of the actual testers. So the testing conduct organizations have to be arm's length from the certifying body. And the certifying body must design a test that has been demonstrated to be a valid test of competence. So that means that psychometricians have to design and validate these tests. It's a fairly elaborate process. So in this context, competency usually is described as the demonstrated ability to apply knowledge, skills, and attributes. And so the tests are supposed to validate that the person being tested has demonstrated these things. So there's a whole industry around this. You might be aware of this. There are a lot of certifying bodies in the IT world, IEEE, ASQ, International Software Testing Qualification Board, the International Requirements Engineering Board, the Institute, I forgot the exact name of that acronym, the Institute for Business Analysis, a Canadian group, and the Project Management Institute, of course, and there are some others. So those organizations are the certifiers. They define a body of knowledge, they design a test, and they process applications. And the applications are usually two different kinds. One application comes from a person who's interested in becoming certified, and you pay some kind of an application fee and a fee to take the test. And then also many of them do some kind of a recognition scheme for providers. So if you, in the case of PMI, for example, you may know there are a group of training providers called registered recognized education providers, or REPs, REPs, and they have to submit their training materials to PMI for review, and they have to pay a fee for that. And then, of course, they offer training and they collect money from applicants. And then the testing body administers the test. They get a fee from the applicants as well, and they report the results back to the certifying body, who then issues and records and keeps track of certifications that have been issued. So there's this is a pretty considerable industry. There are at least hundreds of different training providers, and there are relatively few testing bodies, and the certifying bodies are